What if I told you that right now, in laboratories across China, scientists are developing fiber optic technology so revolutionary that it could make your current internet connection look like a dial-up modem from the 1990s? Imagine downloading an entire 4K movie in less than a second. Picture streaming every movie ever made simultaneously without a single buffer. But here's what's truly terrifying. This technology isn't just about speed, it's about control, surveillance, and a complete restructuring of how the entire world accesses information. China is on the verge of deploying fiber optic networks that are 100 times faster than anything currently available. But while tech giants in Silicon Valley are still debating bandwidth limits, Chinese engineers have already solved problems we didn't even know existed. The question isn't whether this technology will change everything, it's whether the rest of the world will even notice when it happens. If you're watching this and thinking, that sounds incredible, you might want to hit that subscribe button right now, because what I'm about to reveal will fundamentally change how you think about the future of the internet. Welcome to Revo Now, where we decode the technologies reshaping our world. I'm your host, and today we're diving deep into China's most ambitious fiber optic revolution, a technological leap that could redefine global internet infrastructure as we know it. If you haven't already, smash that like button and subscribe, because what we're about to explore has massive implications for every internet user on the planet. China isn't just keeping up with fiber optic innovation. They're about to leapfrog the entire Western world. The term next-generation fiber optics isn't just marketing speak. We're talking about quantum photonic integrated circuits, hollow core fiber technology, and silicon photonics that make current fiber optic cables look like Stone Age tools. But here's where it gets interesting. China has been quietly stockpiling the rare earth materials and manufacturing capabilities needed to dominate this technology for decades. Every major tech company, every government, every telecommunications provider, they're all watching what happens next. Because whoever controls the next-generation fiber optic infrastructure controls the future of global communications. And right now, the chess pieces are moving in ways that might surprise you. To understand the magnitude of what's coming, we need to appreciate where we currently stand with fiber optic technology. Today's internet backbone relies on fiber optic cables that transmit data using light pulses through glass or plastic fibers. These cables can carry data at speeds approaching the speed of light, but they're still limited by physical constraints that scientists have been trying to overcome for decades. Current fiber optic networks operate at speeds of around 100 gigabits per second over long distances. While impressive, this technology faces fundamental limitations including signal degradation over distance, latency issues, and bandwidth constraints that become problematic as global data demands continue to explode. China's approach to solving these challenges has been methodical and comprehensive. Rather than simply trying to improve existing fiber optic technology, Chinese researchers have been pursuing parallel tracks in quantum communications, photonic integration, and novel fiber materials that could collectively represent the biggest leap in telecommunications since the invention of the internet itself. The irony is that fiber optic technology was originally developed in the West. Corning Incorporated created the first low-loss optical fiber in 1970, and American companies dominated the industry for decades. But China recognized early on that fiber optics would be the backbone of the digital future, and they've been systematically building their capabilities in this space since the early 2000s. What makes China's approach particularly concerning to Western technology leaders isn't just their investment in research and development, it's their ability to vertically integrate the entire fiber optic supply chain, from raw materials to manufacturing to deployment. This gives them capabilities that no other nation currently possesses. But here's where the story takes a fascinating turn. China's next-generation fiber optic development isn't just about commercial applications. Embedded within their research are capabilities that could fundamentally alter the balance of power in global communications. Let's examine what's currently available in fiber optic technology and why it's reaching its limits. Traditional fiber optic cables use solid glass cores to transmit light signals. While effective, these systems face several fundamental challenges. First, signal attenuation occurs over long distances, requiring repeaters to amplify the signal. Second, non-linear effects in the fiber can distort signals at high power levels. Third, the physical properties of glass impose fundamental limits on bandwidth and speed. Current fiber optic networks also struggle with latency, the time it takes for data to travel from source to destination. Even at the speed of light, there are delays when signals must travel thousands of miles through undersea cables. For applications requiring real-time communication, these delays can be significant. The global fiber optic market is currently valued at over $10 billion annually, with demand growing rapidly as streaming services, cloud computing, and IoT devices drive unprecedented data consumption. But the technology underlying this market is aging, and the industry is desperately seeking breakthrough innovations. China currently manufactures over 60% of the world's fiber optic cables and controls significant portions of the rare earth materials needed for advanced optical components. This gives them enormous leverage in the global telecommunications infrastructure market. But what China has been developing in secret goes far beyond simply manufacturing more fiber optic cables. They've been working on technologies that could make current fiber optic infrastructure obsolete entirely. China's fiber optic strategy isn't just about building faster networks, it's about building networks that serve their broader geopolitical and economic objectives. This approach involves several key components. Chinese universities and research institutions have been investing heavily in photonic integrated circuits, which integrate multiple optical components onto a single chip. This technology could dramatically reduce the size, cost, and power consumption of fiber optic equipment while increasing performance. China has established itself as the world leader in photonic device manufacturing, with companies like Huawei, ZTE, and FiberHome dominating the global market for fiber optic networking equipment. But their ambitions extend far beyond current market leadership. China's domestic fiber optic network is already among the most advanced in the world, with over 500 million fiber connections, more than any other country. This extensive domestic deployment provides a testing ground for next-generation technologies. Through initiatives like the Digital Silk Road, China is extending its fiber optic infrastructure throughout Asia, Africa, and Europe. This isn't just about providing internet connectivity, it's about establishing control over global communications pathways. But the real breakthrough has been happening in Chinese laboratories, where researchers have been working on technologies that could revolutionize not just how we transmit data, but how we think about data transmission itself. China's next-generation fiber optic research encompasses several revolutionary technologies that could transform global communications. One of the most promising developments is hollow core fiber technology, which replaces the solid glass core with a hollow tube. This allows light to travel through air rather than glass, reducing latency and increasing transmission speeds by up to 50%. China has been leading the world in quantum communications, launching the world's first quantum communications satellite, Mauritius, in 2016. Their quantum key distribution networks provide theoretically unbreakable encryption for sensitive communications. Chinese researchers have made significant advances in silicon photonics, which uses silicon chips to manipulate light signals. This technology could dramatically reduce the cost and complexity of fiber optic networks while improving performance. China is developing photonic integrated circuits that can perform complex optical processing functions on a single chip. These devices could replace entire racks of traditional fiber optic equipment with palm-sized devices. But perhaps the most significant development has been happening in the realm of quantum photonic networks, a technology that could make current internet protocols obsolete while providing China with unprecedented control over global information flows. While much of China's fiber optic research is publicly known, there are developments that have remained hidden from Western intelligence agencies and technology companies. Chinese military and intelligence agencies have been funding fiber optic research programs that focus on surveillance and control capabilities. These programs explore ways to monitor and manipulate data flowing through fiber optic networks without detection. China's control over rare earth materials gives them unique advantages in developing advanced optical components. Elements like erbium, ytterbium, and neodymium are essential for fiber optic amplifiers and lasers, and China controls over 80% of global rare earth production. By controlling the entire fiber optic supply chain, from raw materials to finished products, China can ensure that their next-generation technologies are deployed rapidly while limiting access by competitors. China has been forming strategic partnerships with countries throughout the developing world, offering next-generation fiber optic infrastructure in exchange for political and economic concessions. But the most concerning aspect of China's fiber optic development isn't just their technological capabilities, it's their understanding of how these technologies can be used to reshape global power structures. The deployment of next-generation fiber optic technology by China could have profound implications for global communications, economics, and geopolitics. Countries that rely on Western technology providers could find themselves at a significant disadvantage if China's next-generation fiber optic networks offer superior performance at lower costs. This could accelerate the shift in technological leadership from the West to Asia. Next-generation fiber optic networks could provide China with unprecedented surveillance capabilities, allowing them to monitor international communications with greater precision and scope than ever before. As countries around the world grapple with issues of digital sovereignty and data security, China's fiber optic technology could become a key tool in their efforts to establish alternative internet infrastructure independent of Western control. Western technology companies that fail to keep pace with China's fiber optic development could find themselves locked out of the next generation of global telecommunications infrastructure. But the real game changer isn't just the technology itself, it's how China plans to deploy it and what they've already accomplished that the rest of the world doesn't know about. Now, for the revelation that will change how you think about the future of the internet. What if I told you that China has already deployed next-generation fiber optic networks in over 50 major cities, with speeds that make current internet connections look like dial-up? What if their quantum photonic networks are already operational, providing secure communications that are literally impossible to intercept? Here's what Western intelligence agencies have been trying to confirm. China has developed a hybrid fiber optic quantum network that combines traditional high-speed data transmission with quantum key distribution for absolute security. This network is already connecting major government facilities, military installations, and critical infrastructure throughout China. In cities like Shanghai, Beijing, and Shenzhen, Chinese citizens and businesses are already experiencing internet speeds of over 10 terabits per second. That's 100 times faster than the fastest current commercial networks. But more importantly, these networks are designed with built-in surveillance and control capabilities that make them fundamentally different from Western internet infrastructure. China's next-generation fiber optic networks aren't just faster, they're designed to be controllable. The quantum encryption components ensure that the Chinese government can monitor all communications while preventing foreign intelligence agencies from doing the same. This creates an asymmetric advantage in information warfare that could be decisive in future conflicts. Through their Digital Silk Road initiative, China is extending these next-generation networks throughout Asia, Africa, and parts of Europe. Countries that accept Chinese fiber optic infrastructure are unknowingly becoming part of a network that gives China unprecedented visibility into their communications. The most shocking aspect is that China has been quietly training engineers from developing countries in the operation and maintenance of these next-generation networks. When these countries eventually discover the surveillance capabilities built into their infrastructure, it may be too late to remove them without completely rebuilding their telecommunications systems. Let's dive deeper into the specific technologies that make China's next-generation fiber optic networks so revolutionary. China's hollow-core fiber technology reduces latency to less than 1 millisecond for transcontinental communications. This is crucial for applications like high-frequency trading, autonomous vehicles, and real-time industrial control systems where microseconds matter. Their quantum key distribution networks use entangled photons to create encryption keys that are theoretically unbreakable. Any attempt to intercept these keys would be immediately detected, alerting network operators to potential surveillance attempts. Chinese photonic integrated circuits can perform complex signal processing functions that previously required entire data centers. This miniaturization allows for the deployment of powerful network intelligence directly within the fiber optic infrastructure. China's next-generation networks use a distributed architecture that provides multiple redundant paths for data transmission. This makes the networks extremely resilient to both physical damage and cyber attacks while maintaining unprecedented performance levels. Built into these networks are sophisticated traffic management and content filtering systems that can selectively slow, block, or redirect data flows based on content analysis. This gives Chinese network operators unprecedented control over information flows. How has the West responded to China's fiber optic revolution? The answer reveals a great deal about the current state of Western technological competitiveness. Western research institutions have been slow to recognize the strategic importance of next-generation fiber optic technologies. Much of the focus has remained on incremental improvements to existing systems rather than revolutionary breakthroughs. The loss of fiber optic manufacturing capabilities to China has created a dependency that makes it difficult for Western companies to compete in next-generation technologies. Without domestic manufacturing, innovation becomes extremely challenging. Some Western governments have begun restricting Chinese fiber optic equipment in critical infrastructure projects, but these measures may be too little, too late. The technological gap is already significant and growing. Western telecommunications companies have been consolidating rather than investing in next-generation research, focusing on maximizing profits from existing infrastructure rather than preparing for the future. Military and intelligence agencies are particularly concerned about the surveillance capabilities embedded in Chinese next-generation networks. However, economic pressures often force these agencies to accept Chinese equipment despite security concerns. Looking ahead, what does China's fiber optic revolution mean for the future of global communications? Within the next 5 years, China plans to extend their next-generation fiber optic networks throughout Asia and into major European cities. This will create a parallel internet infrastructure that operates independently of Western systems. Next-generation networks will offer speeds of 100 terabits per second or more, with latency measured in microseconds rather than milliseconds. This will enable applications that are currently impossible with existing infrastructure. The availability of ultra-high-speed, ultra-low-latency networks will transform entire industries, from finance to manufacturing to entertainment. Countries with access to these networks will have significant competitive advantages. As China's fiber optic networks extend globally, they will gain unprecedented influence over international communications. This could shift the balance of power in global affairs in ways that are difficult to predict. The gap between countries with access to next-generation fiber optic networks and those without will become a major source of global inequality, potentially creating a new form of digital colonialism. One of the most concerning aspects of China's next-generation fiber optic development is the surveillance capabilities built into these systems. Next-generation networks include sophisticated deep packet inspection capabilities that can analyze the content of all data transmissions in real time. This allows for comprehensive monitoring of communications without the knowledge of users. The combination of high-speed data processing and artificial intelligence enables real-time behavioral analysis of network users. Patterns of communication, content preferences, and social connections can all be mapped and analyzed. Network operators can selectively interfere with specific data flows, slowing or blocking communications based on content analysis. This capability allows for subtle censorship that users may not even notice. Next-generation networks include massive data retention capabilities, storing copies of all communications for extended periods. This creates unprecedented archives of human communication that can be analyzed for intelligence purposes. When these surveillance capabilities are extended to other countries through infrastructure partnerships, they provide China with intelligence gathering capabilities that rival those of traditional intelligence agencies. The economic implications of China's fiber optic revolution extend far beyond telecommunications infrastructure. Western telecommunications companies that fail to adapt to next-generation technologies will face massive disruption as their infrastructure becomes obsolete. This could trigger a wave of bankruptcies and consolidations. Companies with access to ultra-high-speed networks will gain significant competitive advantages in data-intensive industries like artificial intelligence, financial services, and cloud computing. The deployment of next-generation networks will create new employment opportunities in high-tech sectors while eliminating jobs in traditional telecommunications roles. Countries and companies that invest early in next-generation fiber optic technologies will be positioned to capture significant economic benefits as these networks become the new standard. As next-generation networks enable new forms of digital commerce and services, countries without access to these technologies will find themselves increasingly marginalized in global trade. China's fiber optic revolution is part of a broader technological transformation that could lead to a technological singularity in global communications. Next-generation fiber optic networks represent the convergence of photonics, quantum physics, artificial intelligence, and nanotechnology. This convergence is creating capabilities that exceed the sum of their individual parts. The performance improvements offered by next-generation networks follow exponential growth curves that could lead to capabilities that are difficult to imagine with current technology. These networks are being integrated with other emerging technologies like 6G wireless, satellite communications, and edge computing to create seamless global communication systems. Next-generation networks include artificial intelligence systems that can manage and optimize network performance autonomously, reducing the need for human intervention. The rapid deployment of these technologies could lead to consequences that are difficult to predict, potentially transforming society in ways that current planners and policymakers are unprepared to handle. How should the world prepare for China's fiber optic revolution? The answer requires coordinated international action and strategic foresight. Countries need to invest heavily in next-generation fiber optic research and development to avoid falling behind in the global technology race. Reviving domestic fiber optic manufacturing capabilities is essential for maintaining technological sovereignty and security in critical infrastructure. International cooperation on fiber optic standards and security protocols is necessary to ensure that next-generation networks serve the global community rather than individual national interests. Educational institutions need to prepare the next generation of engineers and technicians to work with next-generation fiber optic technologies. Governments need to develop policy frameworks that balance the benefits of next-generation networks with concerns about privacy, security, and national sovereignty. China's next-generation fiber optic revolution represents more than just a technological advancement, it's a fundamental shift in global power dynamics. The deployment of ultra-high-speed, ultra-secure networks with built-in surveillance capabilities gives China unprecedented influence over global communications. If you found this information valuable, please like this video and subscribe to Revo Now for more insights into the technologies reshaping our world. The future of the internet is being written right now, and understanding these developments is crucial for everyone. The question isn't whether next-generation fiber optic technology will transform global communications, it's whether the rest of the world will be prepared for the implications of China's leadership in this critical technology area. I want to hear from you in the comments below. Have you noticed changes in your internet speed or reliability that might be related to next-generation fiber optic deployments? What concerns do you have about the surveillance capabilities built into modern telecommunications infrastructure? And what topics would you like to see covered in future Revo Now videos? Thanks for watching Revo Now. Remember to subscribe, like, and share this video with anyone who needs to understand the future of global communications. The internet as we know it is about to be reborn, and China is leading the charge. Don't forget to check out our other videos on emerging technologies and their global implications. The future is happening now. Stay informed, stay prepared, and stay connected to Revo Now.
Subscribe to Revo Now and join our vibrant community of forward thinkers, change makers, and revolutionaries.